Hello everyone, welcome to Cloud Tech. So today we are going to discuss questions for beginners. So in this series, we are going to cover the questions starting from beginners, then intermediate, then advanced. We will get a lot of questions that are getting asked in the interview. So let's get started.
Okay, so can you tell me if Java is a platform independent or not? And if it is yes, then how is it?
Okay, so Java is a platform independent language. Now let's try to understand what do we mean by platform independence. So consider you write your Java program on Windows machine and you compile it on Windows machine. Now you want to run the same program on Linux. So you can take that program and run it on Linux without making any changes. So compiling your program on one machine and running it on any other machine or any other device is known as platform independence. Okay. Now let's try to understand how Java achieves this platform independence. Okay, so consider you are a developer and you write the source code. Once you write the source code, you compile your source code using Java C utility, Java C compiler, and you get dot class file. So this dot class file contains the bytecode. Okay, the bytecode is the intermediate representation which is used by Java. Okay, so once you get the dot class file, now this dot class file is given to the Java virtual machine, and Java Virtual Machine has the ability to take the dot class file and run it on the underlying machine. So by using these two concepts, bytecode and Java Virtual Machine, Java achieves platform independence.
Okay, great. Can you tell me what is the difference between JDK, JRE, and JVM?
Yeah, all right. So these are the three important components of Java. So JDK stands for Java Development Kit, JRE stands for Java Runtime Environment, and JVM stands for Java Virtual Machine. Okay. Now, what is the purpose of each one of them? Okay. So consider you as a developer. Okay. So when you are working as a developer, you need to perform activities like you need to write a program, you need to debug a program, you need to develop a program. So for doing any kind of development activity, you need Java Development Kit, as the name suggests. So for doing any kind of development activity, you need to download and install JDK. Okay. Now, if you install JDK, by default, you get JRE and JVM with it. So JDK is a superset. When you install JDK, you get everything. You get JRE and JVM. Okay. Now, once you develop and debug the program, you want to give that software to the clients, and clients just want to run the software. Clients don't want to debug the software. Okay. So if you want to run the software, in that case, you just need JRE, Java Runtime Environment. You don't need JDK for running the software. Okay. So clients can only install JRE. And when you install JRE, along with JRE, you get Java Virtual Machine. And Java Virtual Machine is the abstract machine that runs your bytecode. So JVM accepts dot class file, and dot class file contains the bytecode. And JVM has the ability to take the bytecode and run it on the underlying machine. So in short, to develop a program, you need JDK, and to just run the program, you need JRE. And JVM is the actual component which takes the dot class file as an input or bytecode as an input and run it on the underlying machine. So that is, in conclusion, JDK, JVM, and JRE.
Okay. Can you tell me what is a class loader in Java and what are the different types of class loader?
Okay. So as we all know, while writing code in Java, we write classes. Okay. And a class loader in Java is a part of JVM, which is responsible for loading classes dynamically during runtime. So in short, class loader loads the classes in JVM during runtime. Okay. And it converts the bytecode into machine specific instructions. So let's try to understand the types of class loader. So there are three types of class loader. First one is bootstrap class loader. The second one is extension class loader. And the third one is system class loader. Okay, so what is a bootstrap class loader? So when you try to write a Java application, by default, there is a jar which is known as rt.jar, and it has different packages like java.lang package, java.util package. Okay, so all the classes from rt.jar are loaded with the help of bootstrap class loader. So to load the classes of rt.jar, bootstrap class loader is responsible. Okay. Now there is something called as extension class loader. So what is the duty of extension class loader? It loads the classes which are present in the JRE lib ext directory. So as the name suggests, ext extension. So whatever is within extension directory, all the classes will be loaded by extension class loader. Okay. And system class loader. So while writing your program, you define class path. Okay. So all the classes of your class path are loaded by system class loader. So in short, Bootstrap class loader loads the classes of rt.jar. Extension class loader loads the classes from ext directory, and system class loader loads the classes from your class path. So that is about class loader. And class loader uses delegation model. So class loading follows a delegation model. You have to tell this in the interview, where each class loader delegates loading to its parent before attempting to load the class itself. Okay. So consider, suppose a class loader gets a request to load a class. So before loading the class, that class loader will call the parent class loader and ask it to load the class. And only if the parent class loader is unsuccessful, then this class loader will load that class into your runtime. Okay, so this is known as delegation model. That is about class loader.
Okay. Now we know that string is immutable in Java, but do you know how the string is immutable in Java?
Okay, all right. So string in Java is immutable. So when we say it is immutable, once we create a string object, we cannot change the value of the object. Right? Now you can say, but I have created string and I have changed the value. Okay. So whenever you change the value, a entire new object is created, and the same object is never modified. So this whenever you change the object, a new object is created. This mechanism is known as immutability. So once you create the object, it is immutable for lifetime. You cannot change it. Okay. Now let's try to see how it works internally. Consider this: str1 equal to hello, str2 equal to hello, and you do str1 dot concat world. Okay, and you try to print both of them. Now you might think, when you concatenate world, str1 is changed. No, a new string object is created with the value hello world. Okay, so this is how whenever you do any modification to string, the original string is not changed, a new object is created, and this mechanism of creation of new object is known as immutability in Java.
Okay. Can you tell me where these objects will be stored, or what is a string pool in Java?
Okay, so the string pool is a special memory area in JVM that stores literal strings to optimize the memory usage and improve the performance. Let's try to understand what is literals. So anything that is within double quotes is a literal in Java. So string s equal to, in double quotes, hello, and as we know, this is a literal, so this will go in your string pool. Okay. Now if you try to again declare a string s2 equal to same hello. Okay. Now what will happen? Instead of creating a new string, it will refer the string that is created in your string pool. So this is how it optimizes the memory. So it does not repeatedly create new objects. It tries to reuse the object, in turn optimizing memory usage and improving the performance. So all the literals are stored in Java string pool. Now let's try to understand this with the help of an example. Okay. So here string s1 equal to hello, s2 equal to hello. Okay. So as these two are literals, so this will refer to the same object in the string pool. Now you create s3 and you create a new object out of string. So this new object will go to a heap, as you are explicitly saying that I want to create a new object into the heap. Now, if you try to compare S1 and S2, and we know these two objects are created in string pool. So when you compare S1 equal to S2, both are referring to the same object, and hence the output will be true. Okay. Now, when you try to compare S1 with S3, the output will be false. Why? Because S1 is created in your string pool and S3 is created in your heap. and both the objects or both the references are referring to the different object, one to the string pool and one to the heap. So that is the reason when you compare S1 to S3, the output is false. Okay. So in conclusion, whenever you try to create a string literal, that goes into a string pool, and whenever you try to create a new object, it goes into the heap. So that is how that is all about string pool in Java.
Okay. Can you tell me a few differences between a string class and a string buffer class?
All right. As we saw, string is immutable. Okay. So there has to be some object which is mutable. So we can say string buffer is a mutable. String is immutable. We cannot change the content of string once it is created. It always creates a new object. And string buffer is mutable, which means once you create the string buffer, you can go and change the content of it. New object is not created. Okay. So string is thread safe, and immutable objects are inherently thread safe. Okay. String buffer is also thread safe using synchronized method. Both of these are thread safe. So when it comes to thread safety, you can either use string or string buffer. Performance is slower for string for frequent changes, as it creates new object with every modification. Okay, so whenever you modify the string, a new object is created, and hence the performance is not that great. With respect to string buffer, it is very fast. Performance is good because it is mutable and the same object is modified. Okay, and due to this mutability, the performance is faster. So best for read-only operations. If there are several read-only operations, then go for string. And when you have multiple updates, when you have a lot of modification, then go for string buffer. Both are thread safe in a thread safe environment. In a threaded environment, you can go for either string or you can go for string buffer. Let's try to understand this with the help of an example. The string str equal to hello, str.concat world. So this creates a new object because we are modifying the value, and string will create another string into memory, and str will point to that string. So new object is created. Now string buffer sb equal to string buffer hello. Now you try to append it. So when you try to append the word, it updates the existing object. It updates the sb. Okay, it does not create a new object. So this is why string buffer has more performance as compared to string. Okay, so that is about string and string buffer.
Okay. There is one more class, string builder. So can you tell me the difference between string buffer and string builder?
Yeah, all right. So we saw string is immutable, string buffer is mutable. But when it comes to string buffer and string buffer, a builder, both are mutable. So if you see string buffer is mutable, string builder is mutable. So what is the difference? A string buffer is thread safe. Okay, so in a multi-threaded environment, you have to go with string buffer. And string builder is not thread safe. So there's only one thread accessing your string. In that case, you can go for string builder. Okay, so string buffer is thread safe, string builder is not thread safe. So as it is thread safe and there is a synchronization, string buffer is slower when it comes to performance. String buffer is slower due to synchronization. And string builder is faster because there is no synchronization as it is not thread safe. What are the use cases for string buffer? String buffer is best for multi-threaded environment. When there are multiple threads accessing string, you can go for string buffer. And this is best for single threaded environment where there is only one thread accessing, then you can go for string builder. So in summary, both of them are mutable. String buffer is thread safe. String builder is not thread safe. String buffer is slower. String builder is faster. And for multi-threaded environment, go for string buffer. And for single-threaded environment, go for string builder. So that is about string buffer and string builder.
Okay. Can you tell me how to create an immutable class in Java?
Okay. So creating a immutable class. First of all, let's try to understand what is immutable class. So immutable class is the one, once we create the object, I should not be able to change the content of the object. That is a immutable class. Let's try to see how do we create immutable classes. So first, declare the class as final to prevent the subclassing. If you see, I'm trying to create an immutable person, and I've declared this class as final. Why I did declare this as final? Because I want to prevent subclass. I don't want anyone to inherit from this class and change the behavior. That is the first step. The second step, make all fields private and final. Okay. So I make all the fields. For example, take name. Name is private as well as name is final. Make all the fields as private and final. Do not provide the setter methods. Why I don't provide the setter methods? Because I shouldn't be able to set the value once I create the object of it. So I won't provide the setter methods. So fourth one is initialize all the fields through the constructor. So only during construction of the object, I should provide all the values and set it into all the fields. So once I create the object, I should not be able to change it. That is the reason we provide all the values in the constructor itself. And the last one is ensure deep copies of mutable objects are returned in getters. Okay. So this last example is we don't have it in the example, but consider if you are having a list as an instance variable, so just make a copy of it and then return to the client, so that if anyone changes that list, so they change the copy of the list rather than the original list that is in the person object. Okay. So these 5 things: make the classes final, mark all the fields as private and final, do not provide the setter methods, initialize all the fields through constructors, and ensure deep copies of mutable objects are returned in the getters. So these 5 things you have to answer in the interview. So that is how you create immutable classes in Java.
Okay. Can you tell me what is a wrapper class in Java and why we should go for wrapper class instead of normal primitives?
Okay, all right. So let's try to understand what are the different data types. There are two data types in Java. First one is primitive data type. For example, int, float, boolean. So these are primitive data types. Now, there is one more type of classes known as wrapper classes that encapsulates the same behavior as primitive data type, but these are not primitive ones. These are objects. So when I say integer, so integer is a wrapper class, but when I create integer, it is known as integer object in terms of wrapper classes. Okay. So let's see why we need wrapper classes. Your collection framework. Okay. So in collection framework, you have list, set, and map. So these interfaces won't be able to work with your primitive data types. So they want only objects. So when it comes to objects, what option we have? We can have list of integer, means list of wrapper class. So these collections won't work with primitive data types, and you need wrapper classes to work with them. That is one of the reasons we have wrapper classes. Then we have something called as autoboxing and unboxing. So as we have primitive types and wrapper classes, so the conversion between primitive to wrapper and wrapper to primitive is done using autoboxing and unboxing. Okay, so these are a few reasons why we use wrapper classes. So that is about wrapper class is an object representation of your primitive data type, and your wrapper to work with collections, you need wrapper classes, and for auto boxing and unboxing between primitive and wrapper, there's a concept of auto boxing and unboxing. Okay, and then we have
Okay.
the examples. The integer is mapped to integer wrapper class, character is mapped to char is mapped to character wrapper class, so on and so forth. Let's try to see one example. Here we have created a list of integer. Okay, and we are trying to add 10. Now you will say this 10 is a primitive type, and here auto boxing happens. So this 10 is automatically converted into your wrapper class and added into your list. Okay. Now at line number 3, you try to get that value. Okay. And you try to assign that value to the primitive type. Now what will happen? You will say I have inserted wrapper class into my list, but when I'm assigning it to a primitive type. So this wrapper class is converted into primitive type using a concept known as unboxing. Okay. So when you convert your primitive to wrapper class, it is known as autoboxing. And when you convert from your wrapper class to primitive type, it is known as unboxing. So this is very important for your interview, autoboxing and unboxing. So keep this in mind. Okay. All right.
Okay, so what is a static variable in Java?
Okay. So, static variable. Let's try to understand what are variables. Variable are the ones of which you can change the value. It can vary. That is the reason it is known as variable. Now, there are two types of variables. One is variables that belong to object. Okay. And second type is variable that belongs to class. Okay. So, static variables are class level variables and that are shared among the objects. So consider for an example, I want to count the number of person objects I create. Okay. So as static variables reside at the class level. So if you create three objects, then this static variable is shared between all the object because it is at the class level. So static variables reside at the class level and declared using static keyword, initialized only once at the class loading time and shared by all the objects of the class. So let's try to see an example. Here there's a counter and static int count equal to 0 and increment count plus plus. Okay. Now in the main, we create object 1, object 2, and we increment it twice. So what is the output? As this object, as this variable is as static, it belongs to a class. And when I increment, it is shared between the object and the value is 2. Okay. So static variables are the variables which are at the class level and shared between objects. So that is about static variables.
Okay, and what is the difference between these static variables or class variables and instance variable?
Okay. So class variables are also known as static variables because they belong to a class. And instance variables belong to your objects. Okay. So let's see where these variables belong. So these variables belong, instance variable belongs at the individual object level. So whenever you create object, with that object, you have the instance variable. You have a different instance variable. So when I create P1, P1 will have its own instance variable. When I create P2, P2 will have its own instance variable. But when I declare static variable, it is at the class level. So both P1 and P2 will share the same static variable, which is at the class level. Now, instance variables are stored in heap memory and the static variables are stored in the method area. This is very important difference. Your instance variables in the heap memory and static variable in the method area. Okay. Initialization. So whenever you initialize an object, initialize when object is created, instance variables are initialized when your object is created, and class variables are initialized when the class is loaded. Okay. So instance variables are initialized when objects are created and class variables are initialized when class is loaded into memory. Okay. So sharing, your instance variables are not shared variables. They belong to an object. Okay. But your class variables are shared variables. So class variable, anyone can use that class variable using class name dot that variable name. So that is about instance variable and class variables.
Okay, what is a transient keyword in Java?
Okay, so the transient keyword is used to indicate that the field should not be serialized during object serialization. Let's try to understand. Consider you have an object in memory and you want to save the state of that object. So saving state of an object from memory to a file or converting that object to a stream of bytes is known as serialization. So sometimes we have to save the state to the disk and again we want to take the state from disk. So what we do, we try to serialize the state of the object to the disk. So during this serialization process, there is some important information which we don't want to serialize. So we mark that variable as transient. So consider this example. Here we have a person object which implements serializable. That means this object can be serialized and we mark transient age as transient. Okay. So when I do serialization of this object, then age will not be serialized. Age won't be serialized into the disk. So during serialization process, this age will be ignored. And that is the reason we use transient for not serializing the object. So here we have an example, but we won't go through this example. Okay.
Okay. Can you tell me what are the access specifiers available in Java?
Yeah, so there are four important access specifiers which are available in Java. One is public, private, protected, and default. So let's try to cover the ones which are very simple. So public, when you have a variable with public access specifier, that variable can be accessed by anyone by anywhere, because this is public. As the name suggests, this variable can be accessed anywhere because this is a public variable. Okay, now you have a private variable. A private variable, consider you have a private variable within a class. Now, as the name suggests, this variable is very private to the class, and anyone outside that class won't be able to access this private variable. And if you want to access the value, you have to give the getters and setters. So public, anyone can access it. Private is very specific to the class and no one can access it outside the class. Okay. Now, there are two important things. One is default and one is protected. So let's try to understand that. So protected is default. Okay, so we won't be covering protected and default. You just go ahead and try to understand this from the given diagram. Okay.
Okay, fine. So what is a marker interface and why do we need it?
Right. All right. So marker interface is an interface with no methods or fields. You So within a marker interface, interface is there, but there is no abstract method within it. So now you will say, what is the use of interface which does not have any methods or it does not have any fields? So it is used to indicate metadata or a special property of a class to the JVM or framework. Okay. So what are some of the marker interfaces? Marker interfaces are serializable and clonable. So serializable indicates that the object can be serialized. It does not have, it just gives an indication to the JVM that this object is serializable and it can be serialized. Clonable. So similarly, you can give indication that this object is clonable and it can be cloned. So to give the indication to the JVM, we have marker interfaces, and the marker interfaces are the ones which does not have any methods defined in it, with no methods or fields. Okay, so that is about marker interface.
Okay, can you tell me the difference between an abstract class and interface in Java?
Yes. Okay. So this is a very popular question, and you need to be prepared for this question for your interview. Okay. So, abstract class and interface at the method level can have abstract class can have both abstract and non-abstract methods. So when you have an abstract class, it can contain both the abstract methods and the non-abstract method. Non-abstract method in the are the ones which are concrete method, which has method body. So your abstract class can contain both the abstract and the non-abstract methods. But your interface can contain only abstract method prior to Java 8. Post Java 8, you can have default methods. But we will discuss about the version which is before Java 8. So it can have only abstract methods before Java 8. Okay. So your abstract class can have instance variables, as we saw. Your abstract class can have any number of instance variables. Okay. And your interfaces can have only constant. It cannot have instance variables. Okay. And all the constants are public, static, and final. Okay. With abstract class, multiple inheritance is not supported. Okay. And with interfaces, multiple inheritance is supported. Now, when we say multiple inheritance, it's very important to understand with interfaces, a class can extend multiple interfaces. So that is the reason we are saying multiple inheritance. Okay. But a class cannot extend multiple classes. A class can implement multiple interfaces. Okay. So multiple inheritance is not supported in abstract class, but it is supported in interfaces. Constructor, yeah, abstract class can have constructor, but your interfaces cannot have constructor. Okay. And access modifiers, your abstract class can be private, protected, or public, but your interfaces methods can methods are public by default. You cannot change the access specifier. It is always public. Even if you don't specify, then also it is public by default. Let's try to understand abstract class. So animal is an abstract class and sound is an abstract method. And let's try to see an interface example. Flyable with fly method. Okay, we saw abstract class, we saw interface, and we saw the differences. Okay.
Okay. What is meaning of encapsulation in Java?
Okay, so encapsulation is a process of hiding the internal details of the class and only exposing a controlled interface to the outside world. So this is achieved by declaring the instance variable as private. So let's try to see an example. Okay, so encapsulation is where you combine your data and your methods into a single unit known as class, is known as encapsulation. So you take a class, you take your data and you take your methods, you combine it into one unit known as class, and this procedure is known as encapsulation. Now what you need to do, you need to declare your properties as private, and you need to give getters and setters to interact with the property. Your client won't be able to change the property. They can only change the property with the getters and setters. So whenever they want to change it, you use setter. Whenever they want to get the value, they use getters. So this field is known as encapsulated field. Okay, so that is about encapsulation. Encapsulation is where you combine your code and data into a single unit, and that single unit is known as encapsulation.
Okay. Uh, can you tell me what is polymorphism and how it is achieved in Java?
Okay, so polymorphism, there are two types of polymorphism. One is compile time polymorphism, the other is runtime polymorphism. So compile time polymorphism is also known as method overloading, and runtime polymorphism is also known as method overriding. Let's try to understand this with the help of an example. There's a calculator class, and we have methods with the same name. You see add, but we have different number of parameters. One is taking 2 parameters, the other one is taking 3 parameters. Okay, so in method overloading, you can have methods with the same name, but either with different numbers of parameter or different types of parameter. So here we are dealing with different number of parameters. So this is known as method overloading, and it is also known as compile time polymorphism. Okay, so now I am making calculator and I'm calling a method with 2 variables and then with the 3 variables, and the method is having the same name. A method having the same name with different number of parameters is known as method overloading. Now let's see what is method overriding or what is runtime polymorphism. Here you see animal, there's a method sound, and I'm printing something, and then dog extends animal and I'm overriding sound. Okay, now what is method overriding? So I have overridden this sound method of animal into dog. I have given a different description, or I have given a different method body or implementation in my dog class. Now let's try to see. Okay, so I make an object animal equal to new dog. Okay, and I call animal dot sound. Now what will happen? Whose object is created? The object of dog is created. So whoever object is created, the method of that object will be called. Okay, so when I do animal dot sound, the JVM sees animal, the object type is dog. It goes to the method of dog and calls dog barks. Okay, so this is known as method overriding. So whatever object is created, method of that class will be called. It's known as method overriding or runtime polymorphism.
What is inheritance in Java?
Okay, all right. So inheritance is about parent-child relationship, or we can call it as superclass and subclass. And consider, we'll take inheritance here itself. Okay, so here we have animal class. Okay, and dog extends animal class means dog is inheriting from animal class. Whatever properties animal has, those properties will be inherited to the dog class, and animal is known as parent class and dog is known as child class. So, and parent class is also known as superclass, and child class is also known as subclass. So, inheritance is about parent and child relationship, and child extends all the properties which are public from the parent. So that is about inheritance, and we have several types of inheritance: single inheritance, multi-level inheritance, and hierarchical inheritance. You can go through each one of them. Okay. What is the benefit? You can have code reusability, you can have faster development, and it is easy to maintain. Okay.
Okay. Next is, can you tell me a little about abstraction in Java?
Okay, so abstraction is about hiding the implementation detail while exposing only the essential feature to the user. Now, what do we mean by this? All right. So consider we have to implement a functionality. Okay. And that functionality is very complex. So we don't need to give all the details of that functionality to the user. We just need to give the necessary details. As the definition suggests, abstraction is the process of hiding the implementation detail while exposing only the essential detail. So implementation detail, how it is implemented, I don't need to bother about it. I don't need to tell client how the things are implemented, but I just need to tell them you call this method and your job will be done. So consider an example. Uh, so abstraction is achieved using either abstract classes or using an interfaces. Okay. Now you see we have animal, we have abstract void sound. This is abstract method. Cat extends animal, and cats override this sound method. So animal does not know anything about sound because that is a abstract method. The one who is providing the implementation knows about the implementation. So cat will have its different implementation of sound, and some other animal will have different implementation of sound. So animal equal to new cat, animal dot sound, this is the abstract method, and animal dot eat. So this is a common method which is at the uh, parent level. Okay. So in essence, abstraction is providing the details which are necessary and hiding the details which are unnecessary. So you just expose the details which are relevant to the client. So that is about all the questions for today's video, guys. We'll come up with more questions around this and will help you prepare for the interview. Thanks a lot, guys, for watching, and have a good day. Thank you.